The question is 2.68 into 10 raised to the power minus 3 moles of solution containing anion. Basically, it's an ion. Okay, so it's an anion containing ion An plus require 1.61 into 10 raised to the power minus 3 moles of MnO4 minus for the oxidation of 2 AO3 minus in acidic medium. What is the value of N basically? So let us write the oxidation half reaction as well as reduction half reaction. So permanganate ion MnO4 minus will be converted to Mn plus 2 in acidic medium. So since here oxidation state of Mn is X plus 4 into minus 2 equal to minus 1, X equal to plus 7, and here oxygen state is plus 2. So reduction is taking place with the addition of 5 electron. So here it will be 5 electron. So we can write for this N factor equal to 5. Now consider the oxidation reaction given by An plus. So An plus basically is converted into AO3 minus. Okay, here the oxidation state of A is plus N, and here oxidation state of A in AO3 minus is X plus 3 into minus 2 equal to minus 1. So X equal to plus 5. So here since the oxidation has been taken place, so our N factor for this reaction will be 5 minus N, because since the oxidation is taking place, so our oxidation state will be increased, so N must be less than 5. So our N factor will be 5 minus N. Okay, so let us denote N factor by capital N to avoid confusion regarding this small n. Okay, so this is our N factor and here this is our N factor. Okay, now use the concept equivalence of K1O4 will be equal to equivalence of A plus N. So on equating the equivalence, we will get equivalence of K1O4 which is equal to 5 N factor into moles for K1O4 which is given 1.61 into 10 raised to the power minus 3 equal to equivalence of An plus which is equal to N factor which is 5 minus N into moles which is given 2.68 into 10 raised to the power minus 3. So we get 5 minus N is equal to 5 into 1.61 divided by 2.68. So on solving we get 5 minus N equal to 3. So our N equal to 2. So value of N in this question will be 2. I hope that I made myself clear. Thanks for watching. Have a nice day.
In the question, it has been asked that a mixture of barium oxide and an unknown carbonate, that is MCO3, was heated strongly, and there was a residue whose weight is given as 3.64 gram. And this was dissolved again in 100 ml of 1 normality of HCl, and the excess of acid required for 16 ml of 2.5 normality NaOH for complete neutralization. And it has asked us to identify the metal M in this MCO3 metal carbonate. So let's get started with writing the equation. as it is given here, barium oxide, but barium oxide is an inert compound, so it will not participate in the reaction. It will be remain as a residue. So rest of the reaction is MCO3. So when we will be heating it, it will form MO plus carbon dioxide gas, which will evaporate. So in the question it is given that 4.08 gram of mixture of BaO and MCO3 is 4.08 grams. Okay, and the residue, so this is the residue. In this residue we are having 3.64 grams. So let us find the weight lost here. That is 4.08 minus 3.64. So it is 0.44 grams, which is nothing but the weight of CO2 gas that has escaped out. So now let us find the number of moles for CO2. Number of moles of CO2, which is 0.44 given mass by molar mass 44, which is 0.01. Okay, now the volume of one normal HCl is given. Volume of one normal HCl is given as 100 ml, right? So let us find the volume of one normal HCl used in the dissolution. Okay? So simply 100 minus 2.5, normality volume is given in the question as 16. So on solving this, we will be getting our answer 60, or that is equal to 60 upon 1000, that is 0.06 equivalents. Okay, so this is nothing but the residue. So what were in the residue? BaO plus MO is equal to 0.06 we can write. So to find the number of moles, so let us divide it with 2 because of the n factor, each has 1. So the value will be 0.03. So now let us find the weight of only BaO. Okay, so both is 0.03 minus, let us subtract this carbon moles, that is 0.01. So on subtracting we got 0.02. And we know that the molecular weight of BaO is 104. Okay, so from this now we can find the weight, which comes out to be 3.08 gram on calculating. Okay, now let's proceed to further question. So we have to identify the metal. Okay, keep in mind that is MCO3. So MCO3, let us find. So total is 4.08. We know that. So let us subtract from that the weight of BaO, that is 3.08, in order to find the weight of MCO3. So that is 1 gram. We found it. Now 0.01 mole of MCO3 is equal to 1 gram. Yes. So now let's find out the molecular weight, which will be 1 by 0.01, that is 100. Okay, so now in MCO3, CO3's molecular weight is 60 grams. So total is 100. So for the metal M, 100 minus 60, which is 40 grams. So now think of a metal whose molecular mass is 40. That is nothing but calcium, or Ca. So here our metal is calcium.